You know that feeling? 3D geometry shows up in your math book and, yeah, panic mode. All right, let's get real. Why does it feel so confusing? What's the actual problem here?
It pretty much boils down to this stuff. Sound familiar? Don't worry, you're not alone.
But what if I told you there's a secret to cracking this whole topic? It's actually simple.
Seriously, this is it. If you get 2D geometry, you've totally got this. You really do. Check this out. The only real difference is that one extra letter, Z. That's it. Just look at the corner of your room. The floor lines are your X and Y. That vertical line, that's Z. Okay, so a location is just half the battle. We also need to know, which way are we pointing? This sounds super technical, right? But it's just a fancy way to say which way a line is pointing. And this little formula, it's your secret weapon. If they don't add up to 1, something's off. Think of these as the chill cousin of direction cosines. They're way easier to work with. So what's the real difference? This is where everyone gets tripped up. Let's clear it up right now. So, the takeaway? Cosines are super precise. Ratios are simple and just give you the general idea.
Okay, location and direction. That's it. That's all you need to build any line in 3D.
And it's always the same 3 simple steps. Get a point, find a direction, and then just assemble. And here it is. This is the formula. It puts your points and your direction together perfectly. All right, so lines are 1D, but what about flat surfaces like a wall? For that, we need planes. And believe it or not, any flat surface, a wall, a tabletop, anything, can be described by this equation.
But the real secret to planes is this thing called the normal.
The normal is basically a handle for the plane. It tells you exactly which way it's facing. Simple. So let's bring this all together. We've covered a lot, but here's the absolute core of it. These are your core tools. Once you get these, all those crazy formulas just become, well, easy.
See, it was never about just memorizing a ton of formulas. It's about understanding the system.
So what if the hardest problems are just simple ideas in a brand new dimension?